Hello everyone. So we will try to discuss one more problem on the steam turbine. So in order to compare the PV/TS diagram with the problem, I have just incorporated the whole thing in a single slide. Okay. Now this is the problem. A steam turbine working on a Rankine cycle is supplied with dry saturated steam. This word is very important. The steam turbine working on a Rankine cycle is supplied with dry saturated steam. That means the turbine inlet, whatever you are supplying, what kind of steam you are supplying to the turbine, it is dry saturated. Dry saturated in the sense the state 1 is on the saturated vapor line. It is in the dry saturated condition. What does it mean if it is dry saturated? That means your state 1 is exactly on the dry saturated vapor line. Okay, that means it is not superheated. So this particular word is very important with dry saturated. If he has specified that it is a dry saturated steam, then your state 1 would be on the saturated vapor line. Okay. At what is the pressure? At 25 bar he is supplying. The exhaust takes place at the 0.2 bar. That means the pressure at which the exhaust from the turbine comes is 0.2 bar, and that is even your condenser pressure also. Now, for the steam flow of 10 kgs per second, he has given the mass flow rate, that is steam flow rate of 10 kgs per second determined. So, following factors you have to determine. Number one is quality of the steam at the end of the expansion. What do you mean by quality? Quality is the word used for the dryness fraction. So, where is that? At the end of expansion. End of expansion in the sense it is at the state 2. That means you need to determine what is x2 here. That is one thing. Second way, turbine shaft work, that is WT, you have to determine. Power required to operate pump, that is this one, WP, you have to determine. Next, work ratio, you know that it is net work done divided by positive work, that one you have to determine. Rankine cycle efficiency, you know in the previous problem how to determine it. And heat lost in the condenser, that means what is the heat rejected from 2 to 3, that means what is the heat rejected in the condenser, we have to determine. So once the boiler pressure and the condenser pressures are known, kindly take the properties from the steam table. The properties which I have written here is not complete. You need to take the values of HF, HG, HFG, SF, SG, SFG, VF, VG and VFG at both boiler pressure, which is 25 bar, and condenser pressure, which is 0.2 bar. Okay. The first step is to determine the quality of at the end of expansion. That means you have to determine what is the dryness fraction at 2, that is x2. So how you are determining it? So H1 you need to find it out. H1 is nothing but it is in the state 1. State 1 in the sense, where is the state 1? That is very important. The state 1 is in the saturated vapor line. If state 1 is in the saturated vapor line, that means H1 will be equal to Hg at state 1. Now, what is state 1? State 1 is at 25 bar. So, at 25 bar, what is the value of Hg? You can take it from the tables, that is 2801.7. So, that same value would be your H1 because it is on the saturated vapor line. Second thing, S1, similarly it is Sg at 1, okay, because it is on the saturated vapor line. So S1 is equals to this much. So since S1 is equals to S2, since remember you have followed the same procedure for the previous problem also, correct? So from S1 to S2, it is isentropic process. Therefore S1 is equals to S2. S1 you know what is the value of S1. So since you have calculated in the previous thing, now that will be equal to S2. Where is the state 2? State 2 is in the wet region. If it is in the wet region, how do you calculate the entropy? Entropy S2 is equals to SF plus X into Sg minus SF at state 2. This is at state 2. What is the pressure at state 2? Pressure at state 2 is 0.2 bar. So, at 0.2 bar, you will obtain the value of SF and Sg. Okay, you will obtain the value of SF and Sg. So, this is SFG directly written. Okay, and you know the value of S2. Substitute it, you will get the dryness fraction. Okay, the only unknown in this particular equation is the dryness fraction. So, you will get what is the dryness fraction at state 2. Now, turbine work. How do you calculate the turbine work? That is from 1 to 2. For work it is initial minus final, so H1 minus H2, correct? So, therefore, you know already H1, I guess. H1 you already calculated here. Okay, now what is H2 now? H2 is in the wet region. So if it is in the wet region, again, how do you calculate? Same formula, HF plus X into Hg minus HF at state 2. What is state 2? This is state 2. What is the pressure of state 2? 0.2 is the pressure of state 2. So 0.2 bar, what is the value of HF and HFG? Just substitute it. You already calculated X at state 2, which is 0.77. Substitute, you will get the value of H at state 2, which is H2. Okay, since H1 and H2 are known, you can calculate the turbine work very easily, which is 734.5 kilojoules per kg. Since you have not multiplied any mass here, it is per kg. Now, turbine shaft work output is equals to work output from the turbine into mass flow rate, correct? So it is 734.5 in 10 kgs per second. The unit conversions are given here. Kilojoules per kg is the turbine work output, into mass flow rate is kgs per second. So kgs goes away. Kilojoules per second is kilowatt. So the total turbine power work output is this much. Now, what is the power required to drive the compressor? For this particular thing, you need to find out what is the pumping work, that is pumping work from state 3 to 4, correct? So how do you find out? Same as the previous problem, it is given by specific volume at state 3 into P3 minus P4, which is again initial minus final. So specific volume at state 3. Where is my state 3? State 3 is on the saturated liquid line, both in the TS diagram and the PV diagram also. It is in the saturated liquid line. If it is in the saturated liquid line, then V3 is equals to Vf at state 3. So what is Vf at state 3? Have noted down. What is state 3? State 3 pressure is 0.2 bar. So at 0.2 bar, what is the value of Vf? That would be the V3 for this particular thing. So once P3 is known, you know the value of P3 and P4, substitute it, it will get the work output from the pump, I mean work input for the pump. So it is negative because it is work done on the system. Similarly, multiply the mass flow rate to get the values in kilowatts. Okay, so that is the power required for the pump. Now, how do you calculate the work ratio? Net work done divided by positive work. You know everything, you know turbine work, you know pump work, just substitute it. Positive work is your turbine work, substitute, you will get it as 0.997. Now, fifth one, Rankine cycle efficiency. How do you find out it? So it is given by net work output divided by heat supplied. So turbine work plus pump work is your net work output divided by heat supplied. So you need to find out heat supplied here. You have calculated what is turbine work and pump work already. So now we have to calculate what is heat supplied. How will you calculate heat supplied? Where you are supplying the heat? You are supplying from 4 to 1 here. 4 to 1 here. Since your B state is your state 1 because it is tri-saturated. The steam enters the turbine in tri-saturated condition. Therefore, your state 1 lies on the saturated vapor line. So that is how. Now, so your heat supplied would be how much? It is final minus initial heat supplied. So H1 minus H4. So you know the value of H1, but you don't know the value of H4. So you need to calculate the value of H4. How to calculate the value of H4? I already told you, in order to calculate H4, that is a sentence to be remembered. If you want H4, always calculate the pump work. So you have already calculated the pump work anyhow in the previous step. So pump work is this much, and pump work is given by what? Initial minus final, H3 minus H4. So H3 is this much and H4 is this much. H3 you have calculated? No. So what is H3? H3 is enthalpy at state 3. Where is my state 3? State 3 is in the saturated liquid line. So saturated liquid line, in the sense it will be equal to HF at state 3. State 3 pressure is 0.2 bar. So 0.2 bar, what is HF? This is the HF. So that would be your H3 here. That would be your H3. So once you have got H3, WP you know, H4 you can calculate as so on. So once you have got H4, so you can calculate QS as this minus H1 minus H4. So substitute it, you will get the value of QS. WT and WP you have calculated. Now you have calculated QS. Substitute all the things, you'll get the efficiency. Now, how do you calculate the heat lost in the condenser? Where is the condenser? 2 to 3 is your condenser. Heat lost in the condenser, how do you calculate? Final minus initial. So final is H3 minus H2. Here it is. So you know the value of H3, you know the value of H2. Substitute it and you will get the value of heat lost in the condenser. It is negative because it is heat lost. Hope you understood the problem. Okay, after this you can try this particular problem and submit as an assignment. Okay, if any doubts you can just call me up.